We think storms, floods, and earthquakes are born on Earth. But what if their true trigger lies millions of kilometers away, deep in space? Every second, the sun blasts invisible waves of energy toward us. Energy strong enough to twist our atmosphere, unleash record-breaking rains, and even shake the ground beneath our feet. Scientists now believe that space weather may hold the key to Earth's most destructive disasters, and the truth will change how you see our planet forever. Welcome to Starsky Science, where we uncover the hidden forces shaping our universe. Before we dive deep into this extraordinary subject, make sure to hit that subscribe button so you never miss the mysteries of space that could impact your life here on Earth. Space weather may sound like a strange term, but it's one of the most important fields of science today. When we think of weather, we imagine clouds, winds, and rains here on Earth. But space has its own kind of weather. A constant stream of solar radiation, charged particles, and magnetic storms unleashed by the sun. And unlike a distant storm on Earth, these cosmic tempests can reach across millions of kilometers and strike directly at our planet. The sun is not just a source of light and warmth. It is a raging nuclear furnace, continuously exploding with unimaginable power. On its surface, massive magnetic loops twist and snap, releasing flares thousands of times more powerful than the biggest nuclear bomb ever built. These explosions hurl charged particles and electromagnetic radiation into space, creating what scientists call solar flares and coronal mass ejections. When these bursts are directed at Earth, they can disrupt satellites, black out power grids, and even ignite auroras that dance across the skies. But new research suggests their influence goes even deeper, into the very climate systems and geological forces of our planet. Imagine this. A solar storm slams into Earth, disturbing our magnetosphere. The invisible shield around our planet shakes and ripples like a drum. High-energy particles penetrate our upper atmosphere, altering its chemistry. These changes, though invisible to the human eye, can influence cloud formation, rainfall patterns, and even the temperature gradients that drive storms. Some scientists argue that during periods of intense solar activity, our weather on Earth becomes more unstable, leading to extreme rainfall, unexpected floods, and perhaps even earthquakes triggered by shifting stresses in the Earth's crust. One of the most fascinating studies was conducted by NASA and ESA satellites monitoring solar cycles. They found correlations between peaks of solar activity and unusual weather patterns on Earth. During years of maximum solar flares, certain regions experienced record rainfall, while others suffered droughts. While this doesn't mean the sun directly creates every storm, it shows that the line between space and Earth's climate is far thinner than most of us imagine. But how does this invisible connection really work? The answer may lie in cosmic rays, high-energy particles arriving from the farthest reaches of our galaxy. When these cosmic bullets collide with Earth's atmosphere, they create ionized particles that can trigger cloud condensation. In simpler words, cosmic rays might act as seeds for clouds. More cosmic rays mean more cloud cover, which can lead to heavier rains, cloudbursts, and even sudden floods. Now combine that with solar winds and geomagnetic storms, and you have a cosmic recipe for chaos. Take the example of the catastrophic cloudburst events in the Himalayas. While local geography and weather systems play a big role, researchers are beginning to ask whether sudden bursts of cosmic radiation or solar activity could amplify such events. The data isn't conclusive yet, but the patterns are enough to make scientists pay attention. At Starsky Science, we believe these mysteries are worth exploring, because if we can decode the signals from space, we may one day predict deadly floods, devastating quakes, and destructive storms with greater accuracy than ever before. Before we go further, if you're fascinated by how the cosmos shapes life on Earth, take a moment to subscribe to Starsky Science. Your support helps us bring the universe closer to you, with facts grounded in real science and discoveries shared by NASA, ESA, and leading scientists worldwide. When we think of weather disasters, we usually look to Earth's oceans, mountains, or atmosphere for answers. But more and more, scientists are turning their gaze skyward, realizing that the fingerprints of the sun and space itself are etched into our planet's most violent events. The connection becomes clear when we study solar cycles. The sun doesn't shine with a constant personality. Every 11 years, it goes through a cycle of activity, swinging between quiet calm and furious outbursts. During solar maximum, sunspots multiply, solar flares erupt more frequently, and massive storms of plasma hurl themselves across the solar system. Earth, locked in this dance, feels the consequences. Historical records show curious patterns. For instance, in the mid-20th century, meteorologists noticed unusual rainfall spikes during years of heightened solar activity. Later, in the 1990s, satellite data revealed a link between geomagnetic storms and disturbances in jet streams, the high-altitude rivers of air that steer our weather. When the jet streams wobble, storms can form in unexpected places, floods can hit regions unprepared, and droughts can linger far longer than nature intended. It's as if space weather has a hand in rearranging Earth's climate orchestra, sometimes subtle, sometimes overwhelming, but always present. One striking example lies in the mysterious phenomenon of cloudbursts. These sudden torrents of rain, often dumping more than 100 millimeters in an hour, devastate mountainous regions like the Himalayas. Local meteorology explains them as warm, moisture-laden winds colliding with cooler air at high altitudes. But this explanation doesn't fully solve the puzzle of why these events are becoming more frequent and more intense. Some researchers now suspect that bursts of cosmic radiation, enhanced during periods of low solar magnetic shielding, may tip the balance. Cosmic rays create ion trails that encourage tiny water droplets to cluster and form clouds. If the right conditions align, an unstable system could suddenly collapse, releasing all its moisture in one catastrophic downpour. Could the heavens themselves be nudging the clouds to burst? Consider also floods linked to prolonged rains. Satellites like NASA's TRMM, Tropical Rainfall Measuring Mission, and ESA's Sentinel series have shown that rainfall patterns shift subtly with geomagnetic activity. During strong geomagnetic storms, more energy is deposited in Earth's polar atmosphere, which can change wind circulation far to the south, affecting monsoons in Asia and rain belts in Africa. This means that a solar eruption millions of kilometers away can indirectly decide whether rice paddies flood in Bangladesh or rivers dry up in Ethiopia. But space weather's grip doesn't stop at the skies. Beneath our feet, Earth's crust is restless, and there too the sun may play a role. A controversial but growing field of study looks at ionospheric anomalies before earthquakes. Hours or even days before massive quakes, satellites sometimes record strange spikes in atmospheric temperature, sudden changes in electron density, and unusual radio wave disruptions. What's even more intriguing is that these anomalies often align with bursts of solar or geomagnetic activity. Some scientists propose that solar storms may load additional stress into Earth's magnetosphere and ionosphere, creating conditions where tectonic faults already on the edge might slip more easily. It's not proof, but it's a clue that Earth's natural disasters might not be fully terrestrial in origin. Let's take a step back and look at one of history's greatest space weather events, the Carrington event of 1859. When British astronomer Richard Carrington observed an enormous solar flare, he had no idea it would soon unleash the most powerful geomagnetic storm ever recorded. Telegraph wires sparked with fire, operators received electric shocks, and auroras lit up the skies as far south as the Caribbean. Now imagine if such an event occurred today. With our fragile power grids, satellite networks, and climate systems, the cascading effects would be unimaginable. Beyond blackouts and communication failures, the additional atmospheric energy could drive extreme storms, change rainfall cycles, and trigger unforeseen natural disasters. Modern science is still piecing together these interactions, but the evidence is mounting. NASA's missions like SOHO SDO and Parker Solar Probe are mapping the sun's behavior in detail. Data show how solar winds interact with Earth's magnetosphere like invisible waves crashing against a shield. Sometimes the shield holds, sometimes it wavers, and when it does, Earth feels the consequences. The magnetosphere itself is central to this story. This protective bubble of magnetic fields shields us from most cosmic radiation, but it isn't impenetrable. During strong solar storms, cracks can form, letting streams of charged particles funnel directly into Earth's upper atmosphere. The result? Sudden heating, strange ionization, and altered circulation patterns. Even slight disturbances can cascade into larger climatic shifts. A delayed monsoon season here, a stronger hurricane there. The connections are subtle, but they add up. To appreciate the scale of these interactions, consider how cosmic rays vary with solar cycles. When the sun is active, its strong solar winds deflect more cosmic rays away from Earth. When the sun is quiet, more cosmic rays penetrate our atmosphere. This natural rhythm alters cloud cover and rainfall on a planetary scale. Some scientists suggest that the so-called Little Ice Age of the 17th century may have been influenced in part by a prolonged solar minimum, when cosmic ray influx was at its peak, leading to colder, stormier conditions worldwide. Today, our advanced satellites let us track these patterns with precision never before possible. Missions like NASA's Aqua and Terra satellites measure atmospheric composition, while GRACE monitors subtle changes in Earth's gravity field caused by groundwater shifts and even flooding. By overlaying this Earth data with solar observations, scientists are beginning to build a unified picture, a planet whose climate is in constant dialogue with the Sun and cosmos. The real question becomes, how much of our so-called natural disasters are natural at all? If space weather influences floods, storms, and even quakes, then perhaps every disaster is part earthly, part cosmic. For centuries, humans believed storms and earthquakes were simply Earth's fury, punishment from nature itself. But modern science is uncovering a far stranger possibility, that the real puppeteer may be far above us, hidden in the shifting moods of the sun and the invisible storms of space. Imagine a world where the glow of an aurora in the night sky is not just beauty, but a warning, a signal that somewhere, a flood may strike, a storm may rage, or the ground itself may tremble. This is the hidden language of space weather, and decoding it could mean rewriting the very way we understand disasters on Earth. Every disaster leaves behind a footprint. After a flood, there are mud lines along walls. After a storm, trees lie shattered on the ground. After an earthquake, the scars of fault lines cut through the land. But what if space weather also leaves a footprint? Subtle, invisible, hidden in the atmosphere and ionosphere above our heads. Scientists at NASA and the European Space Agency have been tracking these fingerprints for decades. They've discovered strange electrical currents in the upper atmosphere before hurricanes, mysterious plasma bubbles forming before cloudbursts, and sudden ionospheric disturbances just hours before earthquakes. None of these patterns are random. They whisper a story. That space weather is quietly woven into the very fabric of Earth's disasters. Let's talk about floods, the most common and deadly natural disaster on Earth. At first glance, floods are simple: too much rain too fast. But space tells a more complicated story. Take South Asia's monsoon. Billions depend on it, and yet it can shift wildly from year to year. During solar maximums, researchers noticed something extraordinary: unusual surges of rainfall across India and Bangladesh. The explanation lies in how solar activity reshapes the jet stream, those high-altitude rivers of wind that guide storms. When solar flares or coronal mass ejections hit Earth's magnetosphere, the disturbance trickles down into the atmosphere, bending the path of jet streams. A small bend can mean weeks of relentless rain in one place and drought in another. In 2013, catastrophic floods hit Uttarakhand, India. While local factors like melting glaciers and heavy monsoon rains were primary triggers, satellite data later showed heightened geomagnetic activity during the same period. Coincidence? Perhaps. But scientists are beginning to wonder if these invisible solar storms tip the balance, nudging fragile weather systems into chaos. Cloudbursts remain one of nature's most terrifying secrets. Imagine standing in a village high in the mountains. The sky suddenly cracks open, and within minutes, walls of water crash down, sweeping away homes, fields, and lives. Traditional meteorology explains this as moist air being forced upward over mountains, cooling rapidly and releasing torrents of rain. But this explanation feels incomplete. Why do some mountain regions see normal rains while others are devastated by cloudbursts again and again? Here's where cosmic rays enter the story. When solar activity is low, more cosmic rays penetrate Earth's atmosphere. These high-energy particles collide with molecules in the air, creating showers of ions that act as seeds for cloud droplets. In unstable mountain air, this can supercharge cloud formation, packing clouds with massive amounts of water vapor. One tiny atmospheric imbalance, and the sky empties in a catastrophic burst. Researchers in India and Japan are now studying the timing of cloudbursts alongside cosmic ray data. Early results suggest that space weather may be a silent hand shaping these killer storms. If floods and storms can be influenced by space weather, what about earthquakes? First, it sounds absurd. Earthquakes come from shifting tectonic plates deep underground, far removed from space. But new evidence is challenging this separation. In 2008, before the devastating Sichuan earthquake in China, satellites recorded strange anomalies in the ionosphere. Just days before the quake, the density of charged particles in the upper atmosphere spiked dramatically. Similar disturbances were seen before the 2011 Tohoku earthquake in Japan, the one that triggered a deadly tsunami and nuclear meltdown. Some scientists now believe that solar and geomagnetic activity can amplify these signals. The theory is that stress building deep within Earth's crust releases gases like radon, which rise into the atmosphere. Solar storms interacting with Earth's magnetosphere may then magnify the ionospheric disturbances, acting like a cosmic spotlight on a brewing disaster. If this link is proven, it could transform earthquake prediction. Imagine using space weather as an early warning tool, giving vulnerable regions days of preparation. It's still speculative, but the pieces of the puzzle are falling into place. Hurricanes and cyclones are Earth's most violent storms. They thrive on warm oceans and atmospheric instability, but scientists are beginning to notice that some of their behavior, sudden strengthening, unusual paths, may be linked to space weather events. During major solar storms, Earth's upper atmosphere heats up and expands. This can subtly shift wind patterns at lower levels. A hurricane that might have curved harmlessly out to sea can instead be nudged toward land, causing catastrophe. The infamous Hurricane Katrina in 2005 struck during a period of heightened solar activity. While no scientist claims the sun created Katrina, studies suggest that solar-driven atmospheric changes may have intensified its destructive power. If true, it means the sun is not just fueling Earth's climate, but sometimes steering its deadliest storms. At the center of all these mysteries is Earth's magnetosphere, our invisible shield. Without it, life as we know it could not exist. But the magnetosphere is not static. It bends, cracks, and sometimes even rearranges itself under the pressure of solar winds. When cracks form, rivers of charged particles pour into our upper atmosphere. These particles can supercharge auroras, but they also dump immense amounts of energy into the system, disturbing winds, altering temperatures, and even creating strange ground currents that flow through rocks and soil. Could these currents, in some cases, influence the delicate balance of tectonic stresses? It's a bold idea, but one gaining quiet attention in scientific circles. If we look to the past, we see hints of this cosmic influence again and again. The year without a summer in 1816, caused by volcanic eruption, was made worse by a solar minimum. The droughts of the 1970s coincided with peculiar patterns in solar cycles. And in 1859, during the Carrington event, while technology bore the brunt of solar fury, reports also described unusual storms and erratic weather across parts of Europe and North America. The lesson is simple. Space weather does not act alone, but it may amplify or destabilize Earth systems already under strain. As we step deeper into the 21st century, the stakes are higher. Climate change is loading the dice, making floods, storms, and heat waves more extreme. But layered on top of this is the silent hand of space weather. Imagine climate models that ignore the sun's cycles, the magnetosphere's cracks, or the role of cosmic rays. They are incomplete. To truly predict Earth's disasters, we must see our planet not as an isolated world, but as part of a vast cosmic system. And this realization is not just scientific curiosity, it's survival. Understanding space weather could mean saving millions of lives in the decades to come. The James Webb Space Telescope, JWST, was not just built to take pretty pictures of galaxies. Its most powerful tool is spectroscopy, splitting light into its rainbow of colors to detect invisible fingerprints of chemicals. When an exoplanet passes in front of its star, some of the starlight filters through its atmosphere. Webb reads that faint light, molecule by molecule, revealing what the planet is made of. What has it seen? Worlds with carbon dioxide, methane, water vapor, the building blocks of climate, and maybe even life. But here's where it gets strange. Webb's discoveries are showing us atmospheres in states we never thought possible, where chemistry and physics play by rules that defy our earthly understanding. Take WASP 121b, a giant planet so close to its star that its atmosphere boils at thousands of degrees. Webb's data shows metals like iron and magnesium evaporating into vapor. Winds circle the planet at thousands of kilometers per hour, carrying vaporized iron from one side to the other, only for it to condense and rain down as molten droplets. Imagine storms made not of water, but of liquid metal. Or consider HD 189733b, a world where the atmosphere is laced with silicate particles. Winds blow at over 5,000 miles per hour, hurling glass-like shards sideways across the planet. Here on Earth, a thunderstorm can shatter windows. On this world, a storm could shred steel in seconds. And yet, in these alien extremes, Webb is teaching us about our own atmosphere. By studying how radiation, heat, and chemistry interact in these hostile skies, we're learning new ways to predict Earth's climate chaos. Earth's atmosphere, like those alien worlds, carries fingerprints of change. Before a flood, humidity patterns shift. Before a storm, temperature gradients warp. Before an earthquake, ionospheric densities spike. The problem has always been detecting these signs early and accurately. This is where Webb's lessons come in. By analyzing alien skies, scientists are refining the art of atmospheric fingerprinting. If we can decode faint signatures of water, methane, or carbon dioxide light years away, surely we can detect the subtle signals in our own atmosphere that precede disasters. NASA and ESA teams are already experimenting with this approach, blending space-based data with Earth-based weather models. The results hint at a future where warnings for floods, hurricanes, or even earthquakes could come earlier, buying precious hours or days to save lives. But Webb's discoveries are not just about survival. They are about destiny. Each alien atmosphere Webb studies is like a time machine, showing us what Earth's atmosphere might become under different conditions. On Venus-like planets, Webb has revealed thick blankets of carbon dioxide trapping unbearable heat, leading to runaway greenhouse effects. On smaller, colder planets, it has seen atmospheres stripped away by stellar winds, a warning of what happens when a magnetic field fails. And on water-rich worlds, Webb has glimpsed thick clouds that may resemble Earth's climate billions of years ago. The question is no longer whether alien atmospheres matter to us. The question is, which of them reflects our future? Here's the part that sends chills down the spine. Many alien atmospheres Webb has studied show clear scars from their stars' activity. Some are blasted by solar winds so fierce they lose entire layers of air. Others show chemistry twisted by radiation storms. Does this sound familiar? It should, because Earth too lives under a stormy star. Our sun's outbursts trigger auroras, but also disrupt satellites, destabilize power grids, and perhaps even influence disasters. By studying how alien worlds weather the tempests of their stars, Webb is showing us how our own fragile bubble of air responds to the sun's moods. This may be the key to one of humanity's oldest dreams: true, reliable disaster prediction. We may be entering a new era. Cosmic meteorology, the study of weather not just on Earth, but across the universe, to understand the universal laws that govern storms, floods, and atmospheric collapse. Think of it this way: Earth is one data point. But with Webb, suddenly we have dozens, soon hundreds of atmospheres to compare. Each one is a natural experiment in how chemistry, physics, and solar activity shape weather. The more we study them, the more we learn to read the signs in our own skies. And perhaps one day, just as ancient sailors learned to read the stars for navigation, humanity will learn to read the atmospheres of alien worlds as guides for our own survival. What James Webb is showing us is not just alien beauty, but alien warnings. Worlds with runaway greenhouse gases scream a message about climate change. Worlds with shattered atmospheres warn us of solar storms. Worlds with chaotic weather show us how fragile balance can be. The universe, it seems, is not silent. It speaks through light, through chemistry, through storms. And now, at last, we are learning to listen. For decades, astronomers have dreamed of detecting signs of life beyond Earth. But the truth is, we may already have the tools to do it. And James Webb is at the center of this revolution. Unlike past telescopes, Webb is not just seeing planets. It's analyzing the air they breathe. And hidden inside those thin envelopes of gases may lie the greatest discovery in human history. Scientists call these signs biosignatures, specific molecules that are strongly linked to life. On Earth, the combination of oxygen, methane, carbon dioxide, and water vapor in our atmosphere is not random. It's maintained by the activity of living things. Plants releasing oxygen, microbes releasing methane, oceans recycling carbon dioxide. Detecting such patterns elsewhere would be nothing short of cosmic evidence. Already Webb has sparked debates. In September 2023, data from an exoplanet called K2-18b made headlines. Astronomers announced that Webb may have detected dimethyl sulfide, a molecule on Earth produced only by living organisms, especially marine plankton. Though unconfirmed, the possibility sent shockwaves through the scientific community. Was this the first hint of alien life hiding in an atmosphere far from home? But beyond the excitement of extraterrestrial biology, there's a deeper lesson. By searching for alien biosignatures, Webb forces us to confront the fragility of our own atmosphere. If life elsewhere is rare, then Earth may be uniquely precious. If it's common, then atmospheres like ours may be more vulnerable than we think. The connection to disasters becomes clear here. Our atmosphere's balance is delicate. A slight shift in greenhouse gases can tip it toward extremes. When Webb observes Venus-like worlds with runaway carbon dioxide, it is not just studying alien climates. It is showing us a possible Earth, centuries from now, if we fail to act on climate change. At the same time, Webb has observed rocky planets orbiting red dwarf stars, where radiation from stellar flares strips atmospheres away entirely. These worlds remind us of the power our sun holds. A major solar superstorm could, in theory, have devastating effects on Earth's atmosphere, from satellite destruction to atmospheric heating. Space weather is not an abstract concept. It is a force capable of altering the very air we breathe. Some scientists now argue that by combining Webb's data on exoplanetary atmospheres with Earth-observing satellites, we can build a new kind of warning system. Imagine if unusual chemical shifts in Earth's upper atmosphere could be detected and analyzed the way Webb reads alien skies. We might foresee chain reactions leading to heat waves, floods, or droughts days earlier than current models allow. And then there is the philosophical weight of Webb's work. If life is discovered elsewhere, even in microbial form, the definition of disaster will change. No longer will our greatest fear be losing crops to floods or homes to storms. The true disaster will be failing to preserve the one atmosphere we know sustains life in a universe that may be largely barren. Alien skies are becoming mirrors. In their storms we see our own. In their chemical scars we glimpse our vulnerabilities. And in their possible hints of biology, we are reminded of how extraordinary Earth truly is. As Webb continues its mission, each new atmosphere it studies adds another thread to this cosmic tapestry. Slowly, a pattern is forming. A pattern that tells us weather is not merely a local event. It is written into the physics of starlight, radiation, and chemistry across the galaxy. Perhaps one day, when scientists announce the confirmed detection of alien life, it will not just be a triumph of astronomy. It will be a warning too. A reminder that life is fragile, atmospheres are fleeting, and survival depends on understanding the space weather that shapes every world. When we talk about disasters like floods, cyclones, or earthquakes, it's natural to think of them as purely earthly events. Torrential rains seem to come from clouds. Earthquakes rumble from deep within the crust. Hurricanes spin across warm oceans. But scientists are discovering that many of these forces may have triggers far beyond what we see. They may begin in the invisible storms of space. Studies have shown strange correlations. Days of intense solar activity often line up with unusual rainfall events. It's not that the sun directly pours water onto us, but rather that its storms tweak the delicate balance of pressure and circulation that governs where clouds release their load. In a world where climate change is already destabilizing patterns, space weather acts like a hidden amplifier, turning heavy rains into catastrophic floods. But the sun's influence may reach deeper still. Seismologists have noted that before major earthquakes, the ionosphere above the affected regions sometimes shows anomalies, unusual spikes in electron density, recorded by satellites. Could space weather play a role in destabilizing faults, or are these ionospheric signals a warning system we've yet to decode? The debate continues, but what is certain is that the sky above often whispers before the ground below roars. Satellites have become our silent guardians in this exploration. Missions like NASA's ICON, ESA's SWARM, and Japan's Himawari weather satellites track the upper atmosphere in exquisite detail. They watch for shifts in temperature, radiation, and ionization that may hint at incoming storms or seismic changes. By combining this with Earth-based instruments, scientists are building a layered warning system, a way of linking the cosmic with the terrestrial. This is where James Webb's lessons from alien atmospheres circle back home. By mastering how to read faint signals of gases across the universe, we sharpen our ability to detect faint signals of disaster here. If Webb can spot water vapor hundreds of light years away, surely we can learn to spot the thin chemical trails in our skies that precede floods, hurricanes, or droughts. And perhaps this leads us to the most unsettling idea of all. What if Earth's greatest disasters are not entirely random, but part of a chain that begins with storms on the sun or even cosmic rays streaming from distant galaxies? Imagine a flash of energy born in a supernova thousands of years ago, finally reaching Earth to tip the balance of a storm that floods a city today. In that sense, our disasters are not only local, they are woven into the vast fabric of space-time itself. Now let me ask you something directly. Do you believe that space weather, solar storms, cosmic rays, and galactic energy could really be influencing Earth's floods and earthquakes? Or are these connections just coincidences? I'd love to hear your thoughts. Share your answer in the comments below. And while you're here, don't forget to like this video if you're finding it fascinating. It really helps bring these cosmic mysteries to more curious minds across the world. History remembers wars, revolutions, and natural disasters. But hidden in the background of our timeline are events born not on Earth, but in space. Solar storms so powerful they have crippled our technology, cut communication lines, and left entire nations vulnerable. These moments are rarely discussed outside scientific circles, yet they may be the clearest warnings of what the future holds. The most famous case is the Carrington event of 1859. On a September morning, astronomer Richard Carrington observed a sudden flash of light on the sun, the first recorded solar flare. Hours later, Earth was hit by the largest geomagnetic storm in recorded history. Telegraph lines across Europe and North America sparked, caught fire, and continued transmitting even when disconnected from their batteries, powered only by the energy from the storm. Operators reported electric shocks from their equipment, and the skies lit up with auroras so bright they could be seen in the Caribbean. For miners waking before dawn, the light was so intense that they thought morning had already arrived. This event happened in an age when electricity was still a novelty. But imagine the same storm today. Satellites would be fried, GPS systems disrupted, power grids overloaded. Air travel and internet services could collapse. The World Bank once estimated that a modern Carrington-level event could cause trillions of dollars in damage globally, in a matter of days. But Carrington was not alone. In March 1989, another major solar storm struck Earth. This time, Quebec's entire power grid collapsed in less than 2 minutes. 6 million people were plunged into darkness for 9 hours. The storm induced electrical currents in the ground that surged through transformers, overloading them. Banks, hospitals, schools, all paralyzed by an invisible wave of space energy. More recently, in 2003, the so-called Halloween storms delivered a terrifying preview of our vulnerabilities. A series of massive solar flares and coronal mass ejections hammered Earth for days. Airlines had to reroute polar flights to avoid radiation exposure. Satellite operators scrambled as dozens of spacecraft malfunctioned. Astronauts on the International Space Station took shelter in shielded areas. In Sweden, an entire region lost power. And in South Africa, several power transformers were permanently damaged, leading to rolling blackouts. These are not distant curiosities. They are proof that space weather has teeth, and it has already bitten. Each event reveals how deeply dependent we are on fragile systems. Electricity, satellites, communications. And each one shows how unprepared we remain for the next big storm. Scientists now warn that we are overdue for another Carrington-level event. The sun follows an 11-year activity cycle, and as it approaches solar maximum, the chances of massive flares and ejections increase. Current forecasts suggest we may face heightened risks through this decade. The problem is not whether such storms will come, but whether our systems will withstand them. Space agencies around the world are racing to prepare. NASA's Solar Dynamics Observatory, ESA's Solar Orbiter, and Japan's Hinode satellite keep constant watch on the sun's surface. Ground-based observatories track sunspots like storm chasers. Still, even with all this vigilance, we can usually only give hours, at best a day, of warning before a major solar blast reaches Earth. And when it comes to Earth's disasters, the implications are chilling. A solar storm doesn't just threaten technology, it can amplify weather extremes. Geomagnetic storms heat the upper atmosphere, altering circulation patterns. This, in turn, can influence rainfall, droughts, and even cyclone paths. Some studies suggest links between past solar maxima and periods of unusual flooding or temperature swings. The science is complex, but the fingerprints of space weather are etched into our climate records. Consider this. In 774 AD, tree rings across the world show a sudden spike in carbon-14, evidence of an enormous burst of cosmic radiation striking Earth. No written record describes the event, but the traces remain in wood, ice, and stone. Was it a massive solar superflare? A nearby gamma ray burst? Whatever it was, it dwarfed even Carrington in intensity. If such an event struck today, it could disable satellites permanently, strip ozone, and expose life to harmful radiation. Civilization itself would be shaken. The truth is, Earth has always been vulnerable to space weather. The only difference now is that we live in an age where a single storm can ripple across billions of lives. Our ancestors saw auroras and wondered at the beauty. We see them and wonder whether they signal the collapse of systems we cannot live without. This raises a sobering question. Are we prepared for the day when the sun reminds us of its true power? Scientists warn that it is not a question of if but when. And if history is a guide, the next great space storm may not just light up the skies. It may darken our entire world. The story of space weather is not just about fear. It's about preparation, innovation, and survival. Humanity now understands that the same cosmic forces that once terrified our ancestors can still threaten us today. But unlike those who came before, we are not helpless. For the first time in history, we have the tools to predict, adapt, and maybe even shield ourselves from the storms of space. At the heart of this effort are satellites. NASA, ESA, JAXA, and other agencies maintain fleets of watchful eyes trained on the sun missions like the Solar and Heliospheric Observatory, SOHO, Parker Solar Probe, and Solar Orbiter provide near real-time data about solar activity. They detect sunspots, track solar flares, and measure coronal mass ejections racing toward Earth. Together, they form the first layer of humanity's early warning system. But there is a catch. Even with this vigilance, we usually only get a few hours of warning before a massive solar storm slams into Earth. That's why scientists are now turning to artificial intelligence. By feeding decades of solar and atmospheric data into advanced machine learning models, researchers are building predictive systems that can forecast space weather days, or even weeks, in advance. Imagine an AI that can warn governments to shut down vulnerable power grids before a geomagnetic storm overloads them, or tell airlines to reroute flights before dangerous radiation spikes. On Earth, engineers are working to make our infrastructure more resilient. Power companies are testing transformers that can handle sudden surges. Satellites are being designed with stronger shielding. Communication systems are being upgraded with redundancies. The dream is clear. A civilization that can withstand the wrath of the sun. Some scientists are even thinking beyond protection to prevention. Proposals have been floated to place massive shields in space, giant structures at the L1 Lagrange point, positioned between Earth and the sun, to block or deflect solar storms before they reach us. While still science fiction, advances in materials and space engineering may one day make this possible. If humanity can build starships, why not star shields? And then there's James Webb. While not a space weather sentinel, its observations of alien atmospheres are teaching us universal lessons about how radiation, chemistry, and stellar winds shape worlds. Each exoplanet Webb studies becomes another case study, another warning. The more we learn from those alien skies, the more we prepare for our own. But perhaps the greatest preparation lies not in technology but in awareness. Disasters strike hardest when they are unexpected. By recognizing that floods, earthquakes, and storms may be tied to space weather, we can reshape the way we monitor, predict, and respond. Knowledge is protection, and sharing that knowledge may save lives. This brings us to you, the viewers. Our survival in the face of cosmic storms depends not just on scientists and governments, but on awareness spreading across society. The more people understand the risks of space weather, the more pressure there will be to prepare. That's why documentaries like this matter. So, if you're learning something new and believe more people should know about the hidden link between space and Earth's disasters, I encourage you to subscribe to Starsky Science right now. Together, we can build a community of curious minds, always ready to face the universe with knowledge and courage. Looking ahead, we may see the rise of cosmic disaster forecasting, a field that blends astronomy, climate science, and AI to predict disasters not just from Earth's weather, but from the storms of the sun and beyond. Someday, alerts on our phones might not just warn us of a thunderstorm, but of an incoming geomagnetic surge from the sun. And beyond that, there is hope and unity. Just as climate change has pushed nations to cooperate, space weather may force humanity to work together as a planet. The sun does not recognize borders. Cosmic rays do not stop at passports. If a storm threatens Earth, it threatens us all. In this way, space weather is more than a danger. It is a reminder of our shared fragility and our shared future. When the next great storm comes, and it will, our survival will depend on how well we have prepared and how much we have learned from the warnings already written across the universe. The sun is both our giver of life and our potential destroyer. But with science, foresight, and courage, we may turn even its fiercest storms into lessons that guide us not just to survival, but to a deeper understanding of our place in the cosmos. From the beginning of this journey, we set out to answer a question few dare to ask. Does space control Earth's disasters? And as we've seen, the answer is both humbling and terrifying. The storms that tear through our cities, the floods that drown valleys, the earthquakes that shake mountains, and the strange bursts of extreme weather, all may be touched by forces far beyond Earth. From the sun's nuclear heart, to cosmic rays fired across galaxies, to the invisible dance of Earth's magnetic shield, we are caught in a storm that began long before humanity ever walked the Earth. Our ancestors told myths of angry gods, dragons in the sky, or heavenly punishments when disaster struck. They looked to the skies not out of curiosity, but out of survival. Today, science has replaced myth with measurement, but the truth remains just as awe-inspiring. The heavens do influence the Earth. The sun's solar flares have fried telegraphs, cut electricity, and disrupted satellites. Geomagnetic storms ripple through Earth's crust, sparking earthquakes and volcanism. Shifts in solar wind subtly twist our climate, shaping rains, droughts, and even the intensity of monsoons. Space weather is no longer a distant curiosity. It is a constant, invisible player in the story of Earth's disasters. We have seen the sun as both life-giver and destroyer. Its gentle warmth feeds our crops, drives our winds, and powers the water cycle. Without it, Earth would be a frozen wasteland. But when the sun rages, it unleashes destruction. A single coronal mass ejection could cripple power grids across continents. A solar storm stronger than the Carrington event of 1859 could drag humanity back into darkness in an instant. This duality, creation and destruction, is the very essence of space weather. And it forces us to confront a truth. Humanity is still fragile, still vulnerable, despite all our technology. Beyond the sun, other cosmic forces also leave their fingerprints on our world. Gamma rays from distant supernovae, gravitational shifts from planetary alignments, and the constant bombardment of high-energy cosmic rays all play roles we are only beginning to understand. Could a distant star's death trigger storms on Earth? Could gravitational ripples influence the tectonic plates beneath our feet? These are not just questions for scientists. They are mysteries for all of humanity, reminding us that our planet is not isolated, but woven into the cosmic fabric. In earlier parts, we explored the technologies that may protect us. Satellites scanning the sun's surface, AI predicting space storms, shielded infrastructures designed to endure. These are humanity's first steps in becoming a space weather-resilient civilization. But technology alone is not enough. The greatest shield against cosmic disaster is awareness. When societies understand the threat, they prepare. When they prepare, they survive. So what comes next? Imagine a future where our phones give not just a weather forecast, but a space weather forecast. A notification. Geomagnetic storm arriving in 6 hours. Secure grids. Flights rerouted. Satellites protected. Imagine nations working together, pooling resources not because of politics, but because space weather threatens us all equally. No country is safe alone. The sun does not care about borders. Its storms will hit every shore. At its heart, this story is not about science alone. It is about us, fragile beings living on a small blue world, at the mercy of forces far larger than we can imagine. It is about our courage to study the stars, to connect the dots, and to prepare for dangers most of the world still doesn't see. When the next great storm comes, and it will come, humanity will be tested. Will we be ready? Will we be wise enough to listen to the warnings written across the sky? Or will we repeat the mistakes of the past, caught unprepared as nature reminds us who truly holds the power? The answer depends on how seriously we take the lessons of space weather today. In the end, the link between space and Earth's disasters is not a tale of doom, but a reminder of connection. We are not separate from the universe. The same storms that light up the sun ripple through our world. The same cosmic events that shape distant galaxies leave their fingerprints on our skies, our oceans, our land. We are part of this cosmic story, and by understanding it, we do more than survive. We grow wiser, stronger, and more united. So the next time rain falls, lightning strikes, or the ground trembles beneath your feet, remember, perhaps the storm began not on Earth but in the stars. And that knowledge, that awe, may be the most powerful shield of all. If this journey opened your eyes to the hidden link between space and Earth's disasters, then don't let the story end here. Like this video to support our work. Share it with friends so more people can prepare for the storms of tomorrow. And most importantly, subscribe to Starsky Science for more mind-expanding explorations of the universe. Because the universe is not just out there. It's here, shaping our world every single day.